Brown Dog Gadgets. Live.
Hi there, good afternoon. It is a Thursday. I'm Josh from BrownDogGadgets.com, that wonderful flashing URL on the bottom. And beside me, pressing the button to make that thing flash, is Pete.
Maker tape.
And he loves pressing the maker tape button as well.
Who doesn't?
I regret the day I gave him the control panel to poke
Your
things.
idea.
At least I can't hear the horrible sound effects he subjects everyone to. I imagine it's a rim shot.
Oh, let's do that. Yeah.
Anyway,
Perfect.
we're live streaming yet again because it's 3 o'clock in Central Time Zone, and today we're going to talk about. I can't hold this up, by the way. The green screen's going to screw. Let's go overhead.
Jump right to the overhead.
Yeah, if I do this, the
look
green
at
screen's
that.
going to be
So much going
unhappy
on
with
here.
that. So we're going to be talking about some simple Arduino circuits. These are projects we posted with code. That we will be also posting some simple lesson plans and information on as well here in the next week or so. The first step was making them and doing diagrams and doing the code.
True.
And then we're doing some educational materials. And these are part of some online curriculum we're releasing, free curriculum for basic programming. And while we're doing this with a Crazy Circuits robotics board, which is our Lego-based circuitry board that we have here, but you can also do these with a standard Arduino or any Arduino-compatible board out there. And before I forget, if you like what you see here today, you can follow us at all of these wonderful links. Doo-doo! And hashtag MakerTape, which no one uses, but yeah, follow us. We post lots of videos of stuff we're working on, projects we have coming in, things we're trying to figure out. Upcoming events, and when we do a lot of other projects we don't show on this thing, like little random projects, and we post online that we'll put them up there on those social media links. We do like when people follow us because we do try to post things out there, especially free projects for people and educators especially, because all the resources you see here today and anything we do, we always post on our website for free, whether or not you like our stuff. So also comment if you have messages or comments, which looks like I think Cat Science Club. I can see it randomly off to the side.
Already here.
See Cat Science Club. We can count on them to be like our
ready, Josh,
our homies.
because here to learn.
You are here to learn. That's why we like you,
Awesome.
Cat Science Club.
You got it.
And not just because you're a cat. But these are Arduino projects we've been posting, and yes, Arduino is something that's been done so many times. But I know as someone who had to learn Arduino myself, like all of us, I'm not a programmer, yay free. That it's sometimes hard to get over that initial speed bump of learning curve.
Yes.
And so what we're trying to do is make a bunch of projects that are very linear for a classroom or a homeschool situation or an after-school program that build off each other in a very simple project-based learning format. Now, also, Pete,
Yes.
we do have a higher track level of this as well, hardcore, 3 weeks, hardcore programming intensive stuff as well.
Yeah.
It's really intense stuff, which you can also use. But
Yeah.
this is our more project-based learning track, which I know is more appealing to casual learners in many school environments. But these are part of our classroom sets, or you can buy these parts from us or use other things. But here, so we're going to walk through these because Pete over here has been coding and writing these things.
Yeah.
We're going to show some of these off and talk about how they work and show off some of these resources we've done. And yeah, talk about that. So again, questions, let us know, because we're doing some fun, simple Arduino projects. We like the Lego environment because it's a nice grid-based system, easy to understand, easy for kids to use, and also just easy to visually see what's going on. Because if you're a teacher trying to troubleshoot this via Zoom or a video setting, you can easily see what the heck's going on because it's nice little tiny lines and grids.
Yeah, Josh, I've taught Arduino classes, and you have students with wires and a breadboard, and you're like, well, hold on, and you're leaning way over it, you're staring at exactly where a tiny wire is plugged into a breadboard, and they kind of got to lean aside, and you're leaning in there trying to figure it out. So the tape on the leg is great.
It is, and that's why we put this together, because I was a classroom teacher. You were teaching Arduino at a university level, weren't you?
I taught at a university, and I also taught teens and adults outside of that setting.
Yeah, middle school and breadboards in middle school are just, it looks correct, but it's also a bundle of wires. I don't know what's going on. I hate jumper cables. Even as an adult, for my own projects.
We got a comment here. It says, I'm echoing. I'm going to try to mute myself.
All right.
See if can you still hear me?
I don't
Josh,
know.
Can you hear me?
I can hear you, but you're next to me.
Oh, that's true. All right.
Me has the headset on. I've got this. We're next to each other.
We'll see what happens.
One day we'll move to different settings. We put this whatever.
Yeah.
See if Andy. I'm not gonna yell on the microphone. Maybe Andy will let us know. He's in another room. But anyway, so this is a simple one right here. This is actually, it's a two-position switch, just on and off, and two digital pins. So Pete, let's show the diagram.
Before we do that,
Oh.
Josh, we have a question here.
Cat Science Club. So there's two ways to answer this question. No and no. So our maker tape is pretty inexpensive. We have a couple different versions. This is our 1/8 inch wide, which is perfect for Lego. It goes on top of the studs or between the studs. You can also use the 1/4 inch tape, like this guy here, which is literally just twice as wide. With stuff like this, we use one of these boards with our 1/4 inch tape on paper, or we have one on our wall even, running tape around. It works just fine. So maker tape is pretty inexpensive, about the same price as copper foil. A little bit more expensive, but you use less of it and can do a lot more with it. So I maybe sell like actually I'm having my small rolls over here on the table. Here we have like a 20, we have a 20 meter roll of the 1/4 inch stuff. It's $10 on our website. This is actually not even a full roll. It's missing the middle of it. And we have our, here we go, our smaller 1/8 inch rolls. Here we go. About 16 feet. This is $5 on both our website and I believe on Amazon, amongst other places. We have them all over. We sell them through tons of different places. Robotshop.com carries them, all the educational catalogs and whatnot. NASCO, Demco, Flynn, STEM Supplies, STEMfinity, Go for Sport. I got you. We have a huge list. I always forget people. Go for Sport, okay. Minnesota. And Arduino can be inexpensive. You can buy cheap Arduino boards because it's a pretty open format for a couple of dollars on Amazon. This board right here, our robotics board, which we have on our Crazy Circuits aspect, is $25, which is pretty aligned to like your Arduino Uno, which is like the go-to board. You buy an official one, they're about $25-ish, yeah. I believe. And ours has some nice little pin headers for easily plugging in servos and whatnot, the Lego environment. So that's a nice little added aspect to it. And we add some alligator clips in there and some maker tape when you order it by itself. But usually these come in bigger kits from us, which help cut down the cost of stuff. So you would be easier just to buy a larger robotics kit or our deluxe kit, which has a lot of stuff. Deluxe has a ton. But it can be inexpensive. Even if you just want to use like Arduino on paper with regular LEDs, you can totally do that with tape. So anyway, Arduino is pretty easier. Alligator clips, which we hate. But so Pete, let's throw up the website here.
Let's see if this works. Let's see if this works. Screen. Oh, there we go.
So Pete, I'm going to mute myself while you explain things.
Okay,
and you unmute yourself.
Okay, I should be unmuted now. Yes, hopefully everyone can hear me, or at least Kat can hear me. Good to know. Thank you, says Kat. All right, so over on our website, in the sort of project database section, if you go over to our Crazy Circuits Classroom Set Curriculum, this is part of our Programming 101 project-based curriculum. And this is what we're working on right now. So we have these different lessons, starting from really basic, working your way up. Josh, I think the one you just showed is our switch with 2 LEDs. So for each of these, we've got a little diagram, which looks pretty darn close to what you showed there. Kind of gives you, the difficulty, how many steps, time required, things. There's a little video that shows exactly what you just showed in real life. And there's a little diagram, and it kind of walks you through the components you need and the how to connect them all, shows you a little diagram again. And then again, a little photo showing the circuit. And then what we do is say, hey, upload the code. We might expand this a little if needed, kind of, what to do. But then it has a link to all the code. And now, that one didn't work. Why didn't that one work? Let's try it again. Crazy Circuits. All right, Brown.Gadgets, let's try this. There we go. We'll have to check on that link. But under projects, we've got our Programming 101, and that one was the switch with 2 LEDs. So again, you get the diagram here, and you can get into the code. So that link when it's fixed will go directly to the code. So here's what our code looks like. And this is Arduino Code. So you load this into the Arduino software, and you upload it to the board. And let's see. And then what I try to do here is every line you see with these 2 little slashes at the beginning is a comment. So we tried to comment this code, basically explain what all the lines are doing. So we're setting up a few things like the switch and the 2 LEDs, and then we run a setup routine that's going to basically run once when the board starts up, and it's going to set all these different things. And then we have what's called the loop, and the loop in an Arduino code, it runs forever. Basically, once the Arduino turns on, it runs the setup once, and then it runs that loop forever. So in this case, what it's going to be doing is it's going to check if your switch is in the, we'll say, on or off position, and it's going to do two different things depending on where the switch is. So, if you've never written code, it might look a little weird, but as you kind of work your way through these lessons, I hope it starts to make sense. So that's what we've got there. Anything else I can tell you, Josh, on that? Yeah, I don't know.
I don't think so.
Okay, let's go back to our overhead. So again, yeah, that's what we just saw. We saw the sort of all the materials for that, and let's keep going, I guess.
Cool beans.
Yeah.
So actually, P also knows too.
Yeah.
Your video and the picture you
Yeah.
have, the video you have, is
Yeah.
different. It's you have this guy hooked up differently from
Oh,
this.
really?
You have the from the digital pin here. Digital pin D1 goes to the center spot.
Yes.
And
Does it work?
It works fine.
Okay, because I rebuilt this quickly for our demo, and maybe I just.
Well, the video also has it wrong too.
is it
I noticed.
wrong? Oh, well,
Why is it
we'll
different
take a
from the-
look. We'll take a look. At
Well, I just know from being a
We're
teacher, if like
working through
the
it
video
all.
and the diagram
Right.
are slightly different, people are like,
Yes.
what? Even though like
Yeah.
if you took it like, oh, whatever, it doesn't matter which one you hook it up to.
We're
I
not
just-
done, Josh. We're working through all
We're
this.
still-
We still need the
still working.
QA
So-
process.
So you could do, by the way, you could make this circuit with an analog circuit very easily, just having power come in, and then this is a two-position switch. You could have power come into the center, and then split between left and right to go like this. But this is digital. It's a digital signal being sent, and the controller is the one dictating which of these is actually on.
Yeah.
With a common ground here. So
Oh,
it's-
hey, Josh, so you just have to move the switch over one position to the left. That's
Oh.
what I did. I just had it in the wrong place.
oh
It
yeah,
still
that,
worked, though.
that- this is
Didn't
what the
work either
diagram.
way.
This is what the diagram is. Duh. We have to
I
rebuild
just
this.
put the switch on wrong because I had to grab a new switch when I built this earlier. So that matches
Switches
the
be
diagram.
switching.
Yes. There we go.
Oh, people are commenting. Galore. Look at all these. Are
Oh,
we just
yeah.
letter E's again?
Oh, so Kat said live, gotta love it, and then says upload how. So there's a USB cable. I'll explain how.
So this is a USB cable. Actually, so you plug in Arduino to your computer, same like a microbit or any other USB device. There's Arduino software. It's free, and you just have to go in there. It's literally like it's a text window basically. Pete's gonna download it and install on that computer so we can see it. But it's a little window. You just copy paste into it. You have to set it up by choosing which board it is, which like output port from your computer, which USB port it is. It's pretty easy setup. There we go. Arduino.
software there. You download it for these different systems. Yeah.
Anyway, Windows or Mac, and then you can upload it that way. There's a little button, upload. Once everything is, you've chosen everything, like the right board, you've chosen the right board. It's this one, which output port it is, and then of course if the code is correct, if it, you just hit a little upload, it goes zoom to it, and it'll restart and then run your simple code.
Yeah.
Very simply like this. Boop 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 boop. Speaking of things that make sound, let's move on to the second one we have here. We've got 4 things. 1, 2, 3, 4. It's one of those days.
It is.
I was on hold for 45 minutes recently, so I am just gonna have some fun. Speaking of sound, you can do fun things with piezo speakers. I like sound outputs sometimes. So let's go over what's in here before we start making lots of noise. Again, this is a robotics board. We've got a very simple piezo speaker here. And piezo speakers just do little beep boop sound effects. They're not great little speakers, but they do little high-pitched beepy sound effects. They're fine. We've got ourselves over here. This is a light detecting resistor. I'm going to come in closer to this. Actually, no, Pete, we're going to switch to the close-up camera.
Okay, ready?
Close-up camera.
Close-up. Did it work? All right.
Look at that. So this is a light detecting resistor, also known as an LDR. You've actually probably seen these before on outdoor garden lights. You just didn't know what you were looking at. These are nice because its resistance changes based on how light or dark it is. When it's dark, it has, I believe, infinite resistance. And when it's light out, it's zero resistance.
Yeah.
And then we have a little resistor here to help our Arduino understand what's coming through this circuit. But basically, the Arduino gets between 0 and infinite.
So the fun part, okay, so Josh, with our switch, we basically just closed a circuit. But what's happening here is there's 5 volts feeding through this and then going to ground, but also to one of our analog pins. And so that's but we're using the resistor to kind of feed part of the voltage off to ground, so closed circuit. So yeah, the analog pin is going to get some voltage, somewhere between 0 and 5, depending on how much light is hitting it.
Okay, we'll go back to the other camera.
That makes sense, right?
Well, and the thing is too, it can basically say like it gets a number.
Yep.
So the amount of darkness it is, it gets a certain number. You could even like if you took a light like we have here that we can actually dial up and down different percentages, our studio lights. We could actually get a number output from this to our computer and say, okay, at 50% brightness, it's this number. And then we could tell the code, okay, when it's in this number, it plays this musical note.
Yeah.
So you have a lot of it's not super accurate. It's pretty accurate. Within a range, it's between X and Y. You have a little range of things. So it's not like exactly this. But you get a nice little range and do sound effects with it. And this basically is a phototheremin. You know, the theremin, the little woo. Did you like that?
That was pretty good.
Good. I've been practicing at night in the mirror. Like a theremin, it's doing the amount of light or dark hitting it changes the sound coming out of here. And so we're going to do that. We're going to plug this in and see if I can.
This one's a good one.
I can plug things in. I'm an adult.
I like the green board. Try it on the table too. It might work. It might work there. Put your hand over that.
Well, it's microphone.
Yeah, it's true.
Anyway, that's enough of that.
Yeah.
I'm done making sound effects. But it's a nice little way to do sound output, because you can do the same thing with, say, a potentiometer, by turning a knob. Again, you're getting a variable resistance, which then outputs to sound through your Arduino. And it can make a nice, fun sound effect kind of thing. Instead of having an output like this, you could use a light detecting resistor and a set of LEDs. So as a night light, darkness, LED turns on. When it's light, it turns off.
Fun fact, Josh, the lesson right before this one is with an LED. So what we do is we start with the LED and then we move over to say, hey, can we do this with, you know, a something besides an LED, like the piezo, and we can.
We'll just move this microphone back and forth till we get a better. This is the only headset we could buy was the $2 headset Pete's wearing, because they're all sold out. Thanks, COVID. Yay. So this is another easy one to do. I mean, doing things with light detecting resistor is a really easy thing to do. It's really easy to wire up. It's just a 10,000 ohm resistor. We're using a little screw terminal part here to make life easier, so it's more solid, looks better, more solid build.
There,
and there's Pete's the diagram.
The diagram explains what you need.
Yeah, so it's one of those easy circuits that you can then expand, because there's a lot of, you think, okay, light and dark does something. That's great. Heck, we could hook a servo up into here, and depending on the amount of light hitting this, the servo moves back and forth based on the amount of light. There's so many different outputs you can do. Another fun thing to do would be like using, say, a strip of neopixels, and you could even just have like a bar. The darker it is, the more LEDs light up, or something like that. Super easy to do once you get the basics of, okay, how do I interpret this, and then take that number you're getting from here to do something with. So that's always a fun thing to do with an Arduino and a sensor, because sensors are fun.
Yes, Josh. So it's all about input and output, basically. Like, you know, what are we taking in? What are we listening to? Is it a button press or a potentiometer or a thumb switch? And then what are we doing with that? Are we moving a servo or blinking a light or making a sound?
Speaking of potentiometers and thumbsticks, that's what we've got here. So we've got this little fun joystick guy, which is, okay, he's double-sided taped onto this.
You can pull it off.
Oh.
Let's take it to the table.
Yeah, there we go. So we're getting right in the middle of this video screen. So this thing here actually is a thumbstick. You can maybe see from the side here. It's actually just two potentiometers, and when you move it back and forth, the potentiometers are variable resistors. When they go from like 0 to a certain amount of resistance and everywhere in between. So when we move this, it's going from a 0 to I think 5,000 ohm, if I remember looking up the data on these correctly the other day, and I was. And it just knows where where it is in this here. And we've got two of them, so you can do left, right, and forward and backwards. And so in this situation, we've only hooked up one of the potentiometers, sending a signal here, plugging in via our pin headers there to a little servo here.
Yeah.
So when you go all the way this way, it's probably at 0. All the way this way, it's 5,000, and it goes back. There's a little spring in it, so it goes to the middle, and it's probably 2,500. Yeah. And
so the numbers you're giving, Josh, is the resistance of the potentiometer. Those don't matter as much because what the Arduino is saying is a signal between 0 and 5 volts, which it maps to 0 to 1024. So a little translation of numbers there, but yeah, I think you can move it just a little bit too and get it to go.
Oh yeah, we just
Not
do
all the way. Yeah, just a little bit. Oh, there you go. And when you get back to the center, it'll kind of jump to the center. So yeah.
It's fairly accurate, doing something with the potentiometer. If I had I didn't bring any either. We usually had some on the table here. We have little blue knob ones. You just turn the little knob. You can just slowly turn it, and the potentiometer the servo slowly turns. It works pretty well. And you can hook up, say, 2 of these left, and do like fun sweeping motions with 2 of them. And that's where if you had, say, like a sock puppet or something with a couple of servos on it, you could have like that whoa sock puppet head. If you want to go the sock puppet route.
And we do have potentiometer with servo as well. That's
There we
another
go.
one of the lessons we do have.
And that's the potentiometer that we use with our kits.
Yeah.
And same exact same thing you're doing, like exact same code, exact same thing. Just the thumbstick is way more interesting to look at.
Yeah. So I made the thumbstick so it would because the thumbstick pops back to 0. So I kind of made it, or not 0, but the center. So I kind of added a little buffer in there. But yeah. Cool.
Yeah, that's exactly the exact way your video game controllers work too. So that's a fun one. Video game controllers be like this. I had too much fun with this. So yeah, that's a good one to do. Potentiometers are really fun to control things.
Josh,
when you got servos.
did you try pressing on the? Well, nothing happens, but there is a button. There's a button as well.
Yeah, I like these little thumbsticks. They're pretty inexpensive. They've got a built-in button on there. They've got the back and forth, which if we had another servo or anything's hooked up correctly, but there's a button press too in there.
Yeah.
And these come in one of our classroom sets we have. But we do like to use those for quite a few things, and we'll be using those for some fun new projects in the future. We've got one more thing to do. One more thing.
One more.
We're going to get out of here and going to be done. Live streaming. Always live streaming. It's my idea. All right, so here's another one. We've got 4 LEDs. Now I wonder what's going to happen when I start pressing these buttons. Oh!
Yeah, well, can you press them all at once, or 2 or 3, or there you go.
When our powers combine, we form Captain RGB. So in this situation, pretty straightforward. We've got 4 buttons. They all go down here. From each of these is a digital pin. Digital pin for input and output. We've got our common ground coming this way. This is what we're coming here. All these guys come from digital pin to the push button to a common ground, which is going back here. Our little white spots on our components, that's the ground. It's very easy to do that. These are all negative ground. This is our negative ground. Yay. Anywho, so doing that, we got ground. Common ground, and you press this, and basically button press equals LED turn on. Now, as opposed to, say, just having a simple circuit with a battery and an LED and a push button. There's my LED battery. A battery, an LED, and a here we go, push button. I could do something very similar, but it'll just be analog. It's dumb. Push the button, power flows through. Lift up, it doesn't. In this situation, it's the microcontroller controlling which thing turns on and off.
Gosh, we could easily inverse the logic so that they were always on until you press the button, or we could make it so when you press button 1 turns on. You press 2, maybe 2 of them turn on, and and so forth.
Or you press a button and it goes doot doot doot. It does an animation.
Could do that, right?
My front camera has stalled at a very awkward video spot.
You know what though? We're gonna look over here at the code meanwhile. So
maybe that camera will come back again.
It might.
That's really awkward.
So our code, basically we're setting up 4 different buttons and 4 different LEDs, and we're setting those buttons as inputs and our LEDs as output. And from there, what we're doing is our loop, and we check if each button is pressed or not. And then if it's pressed, we turn on the LED. If it's not pressed, we turn it off. So again, it might look a little foreign and weird if you're not familiar with code and programming, but we hope it starts to make sense as you work through these things.
Let's see if I can come back. I am, but I'm out of focus. Whoa, maybe I can.
I can go press the button.
Yay. Thanks, camera one.
All right, that's okay.
Which
Keep going. Keep
every now and
going.
then does that.
I'll
All right,
press
so
the
I'm.
button.
Why don't you go press the button? Well, we're going to end here shortly anyway. I guess press the button so I'm not horribly out of focus. But anyway, these are in our classroom sets. You can see the project-based learning things that we're doing. We're slowly going through and adding the learning material as well, the like a 1 to 2 page student guide on how this works with a little bit of questions to go with it, so that if you're a student or an adult learning how to do this, here's our example, here's how it all works. Now try changing a variable in there. As Pete said,
Right.
it's supposed to be always on, or always off until you press. How about always on until you press? So we can change small variables and understand through project-based learning versus just theory. And it's more and more fun to make things anyway. And again, if you want to as well, you can just use, say, raw LEDs with some maker tape on a piece of paper. We like the Lego because it's way easier for us to transport around the office and it doesn't fall off. Oh, number 2!
That was number 2.
Number 2!
I numbered it.
You did. Thanks, Pete. And they're also green screeny. Ooh.
Yeah.
Yeah, green screen. And
That's what color plate.
yeah, computers that shut off randomly. We've got a camera that freezes randomly.
You know, we do have, though, free stuff on our website.
It's true. Thanks, Cat Science Club. Free science stuff. People who are still watching, thanks for watching us. We're happy that you're
Exactly.
here.
Because we're cool.
Oh, yeah.
And great ideas. We have those too.
It's true. Now, the cool thing is, too, like, we're showing some very basic things like input, outputs.
Mhm.
I always like bringing things like a temperature humidity sensor. We use some of those in our projects as well.
Yeah.
As a very basic ultrasonic distance sensor. That's a great one to use because it looks like 2 little eyeballs, really, like robot eyeballs. But it's I think up to about 200 centimeters, like 1 to 200 centimeters that it can give you a reading for, and you can output that to things like a display or LEDs. Or my favorite one I've ever seen someone do is they have one of those distance sensors with a strip of LEDs, and basically it's a car park. It like lets them know, like, when it gets to the very end, it starts at like white, yellow, red, which is stop your car.
Yeah.
And that's all it is, just a cheap strip of LEDs, an Arduino, and that distance sensor to help this person park their car, as opposed to the classic tennis ball on a string.
Josh, I have one of those that every time I walk in the garage, I like to walk into it. It's terrible.
Well, it's like our C stand here. There's like the end. I'm always afraid I'm going to
Hit my
hit
head
my
on
face
that.
on it. We've got various things on it. It's a tennis ball.
Yeah.
They're great.
Josh, we got our friend Maker Blocks that he just placed an order.
Now, you're the
That's
one who placed the order for
exciting.
$16. I saw it on my phone when no one was
Just
looking.
getting some maker tape.
Maker
Yeah,
tape.
Man, maker tape. There you go.
Don't spend it all in one
that's
place.
fun. Get
Now
some
keep in mind,
maker
maker tape, besides just looking awesome, and believe me, it is the coolest looking tape you'll see.
It's pretty cool.
You rate a 10 out of 10 by people you don't know. It's also conductive on top and bottom, so if you can't see here, Pete made like your common ground here. He didn't do like fun right angle turns, it's overlapping, which is great. I love the fact it's conductive on top and bottom. Makes for really easy connections.
Josh, did you see when I put it under the microscope or not?
Wait, you put it under a microscope?
Yeah, you didn't see that one?
I don't watch your Twitter feed as much as
Okay. Let me find
as
it.
Pete's like trying to look through like
Let's see if I can
8,000
find
Twitter
it.
posts.
Yeah,
He is an
oh,
expert
it
on
doesn't
Twitter.
belong to me.
It's a woven
It's
fabric.
pretty
It really is
cool
just, it's
looking,
woven
though. Let's see if I
nylon.
can find it.
If you think like conductive thread, it's just woven that, basically. It's a nickel and steel,
Scrolling.
conducts very well.
Yeah.
Just look through your media. You've got so
I
many.
can't because they're not logged.
How far back is it?
I did it a while ago.
There it is. Oh, you went
see
past it. I just saw
You
it.
See it? That's a cat. Oh, no, that's
No,
not
keep
it.
going. Keep going.
Keep going
I
up?
totally. No, down.
Down?
I just saw you go past it.
Really? Oh,
Right
here it
there,
is. Let's
yeah.
see if we can see that.
Let's bring it in from
Let's
the
see here.
hot from Twitter.
Look at that. That's under a microscope. The maker tape.
We're posting that on our Twitter account.
Yeah, I'll get a better photo of it. That's pretty.
That's pretty good. I mean, for what it is.
Not bad, not bad.
And our 1/8 inch and a 1/4 inch tape is just the same tape, just thinner. I actually have some strips of like 1 inch wide tape for some weird reason that we just got for the heck of it from our manufacturer.
Yeah.
Like, sure, why not? Whatever, we don't use it for anything.
Josh, you know what I did with that too? I did add hashtag maker tape on that post. So I mean, you should have seen it.
All right. So Pete, how many people are actually watching us still, according to our little
18 left. You know.
Wow, they went down from like 36 once we started kind of going off the rails like
Cat's
usual.
still here though.
So Pete, let's talk about old movies
Oh,
again.
the content. Damn it.
No. The upside of the maker tape is just that it's extremely durable. You really cannot rip the 1/4 inch stuff by hand. You have to really brute force your way through it, which is
Yeah.
great because kids can't. but it's easy to cut with scissors because it's just nylon strip. It's conductive on top and bottom, and one fun thing, because it's so strong, you put it onto a surface and then peel it off again when you're done, unlike copper foil, which you have to scrape off with a safety blade, like a razor blade
get
or
all
something.
the residue and goo off.
Ugh. Well, it works well with Lego, and even this, our 1/8 inch, does great because it goes atop of the studs or between the studs for a double layer circuit board.
Yeah.
It's super fancy, which we do on a couple, fancy,
Do.
on a couple things like with our potentiometers. You have to kind of do a little under sometimes, just the layout. But anywho, that's our stuff. These projects and more are available at browndoggadgets.com. Doo-doo. If you make something cool, share it with us. If you don't make something cool, share it with us. But a lot of our projects aren't cool, but we make them anyway because it's like, why not?
Yeah,
And
why not?
this episode brought to you by this really nice nylon USB
Josh, a little
cable.
late for this one, but what are you guys making? That was
Nolan, you're
I have
late.
to Wait for the video to
You gotta
end
go
and
watch
then
us on YouTube.
play
We finish it.
again.
We made like
Yeah.
4 Arduino projects, Nolan.
Yeah.
No, we're done, Nolan.
Right.
We're done. We're gonna go back and do paperwork again. This dog needs to get walked. He's below the desk. But you can find all these things for Crazy Circuits and more at browndoggadgets.com.
You can.
And we're posting more of these projects. And we'll be posting a bunch of crud for Microbit later on. Most of these are the same projects, but with Microbit. And then more, because we're doing a bunch of cool stuff with Microbit lately. And we have a bunch of cool new Lego sets that showed up the last couple of days. That's right. Legos. I buy Legos for the office. Cool new Lego things we'll be putting together and doing crazy stuff with here next few weeks, including a gigantic Lego carousel, which is going to get like the best treatment ever, the most fabulous, amazing treatment.
It's going to be neat.
Should be
Neat.
some of the LEDs. Anyway,
Right.
we're done.
We're done.
Thanks everybody for watching.
All right.
We'll be back tomorrow with a weekend recap or something like that.
Do that, yeah.
But otherwise, thanks for watching, and
All right.
thanks for our camera for stalling when I had a weird face going on. Thank you, camera.
Okay.
Camera 1.
Okay. We're done.
Thanks, Cat Science Club. Goodbye.
Okay.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. Check out our live streams at Facebook, YouTube, and Twitch. We'll see you next time.